Hey, Borger High School, what's up? We're going to be talking today about Unit 4, Atomic Structure and History. The essential knowledge and skills you're going to be covering today are C6A. You're going to understand experimental design and conclusions used in the development of the modern atomic theory, including Dalton, Thomson, Rutherford, and Bohr's experiments. Oh, hairball. C3F, you're going to research and describe the history of chemistry and contributions of scientists. C6D, you are going to use isotopic composition to calculate average atomic mass of an element. And you should be switching windows, and for some reason you're not. Okay, let's see here. First of all, what it is you're looking at right here is a little guy made out of carbon monoxide molecules. Each one of those little balls that you can see in there, you see there's some right there, some right there. Each one of those is a carbon monoxide molecule. They have been placed piece by piece to make this tiny little statue of a guy. Now, you may not be all that impressed with that, but once you get some kind of concept of how tiny these atoms really are, it's a super, super impressive thing. Okay? Let me see here. We're going to start off with our history talking about atomic theory. Now, the idea of the atom is something that came from the ancient Greeks. They believed that you could take any piece of material, you could cut it and cut it and cut it until it got so small that you wouldn't be able to cut it anymore, and they called what you could not cut anymore atoma, which means not cuttable. Okay, and it's from atoma that we get the word atom. Okay, and the gentleman that you're seeing right there is I'm not sure if you say his name, Democritus or Democritus. Okay, some other places you may have heard his name. He's the one who came up with the idea of democracy. Okay, it was all his idea. So, you know, that guy, thank you. Later on there was, well, you've probably also heard of Aristotle. He was one of the three big philosophers in ancient Greece. You know, you had Socrates, you had Plato, and you had Aristotle. Aristotle said that, Democritus, you are full of baloney, because we all know that all matter is made out of the four elements, and his four elements were earth, fire, air, and water. And so, by kicking, surefire way of dealing with somebody who you don't agree with is to, kick him out so they can't keep arguing with you. And that's exactly what he did. And this really set back the study of matter for hundreds of years. It wasn't until 1700s that we kind of reversed, the role, and we looked back at what Democritus had done and said, hey, this guy was probably really on something when he talked about, atoms being something that tiny. And so, it just kind of goes to show you that just because somebody's smart doesn't necessarily mean that they're right. Now we're going to talk about John Dalton. Modern atomic theory really starts with this guy right here. Okay. Now, just to kind of give you an idea of how awesome Dalton is, we're going to be switching over to Sean Connery voice. Okay, so here goes. There's John Dalton.
The ancient Greeks used to believe that everything was made up of very small particles. Well, I did some experiments in 1808 that proved this and called these particles atoms. And there's an atom right there.
Now, Dalton didn't exactly know all the bits and pieces of atoms. We now know, thanks to several experiments that we're going to be talking about, all the stuff that we're going to be talking about right here. But you can see that our modern picture of the atom, you've got tiny electrons which have a negative charge, very tiny mass, orbiting a nucleus. And in the nucleus you've got two kinds of particles. You've got protons, which, while they're also extremely tiny, they are hundreds of times bigger than the electrons are. Okay? Protons have a positive charge equal to an electron's negative charge. There's also neutrons, which have the same mass as protons, and they're also in the nucleus, but they don't have any charge. Okay, they serve a different purpose inside of an atom, and we'll get to that later, I'm sure. Now, Dalton's atomic theory had four main parts to it. First of all matter is made up of these tiny things called atoms. Next up, not all atoms are the same. If you've got atoms of a certain element, they're all absolutely identical to each other. So if I've got a bunch of carbon atoms, they're all going to be identical to every other carbon atom everywhere. And they're all going to be different from, say, an oxygen atom or a gold atom or a lead atom. Different atoms are unique, okay? Atoms from two different elements are definitely not the same. His third tenet was that atoms of the same element all have a certain average mass, and we'll talk about what that average means because that can get a little bit confusing, because the numbers that you see on a periodic table and talking about the mass of an atom are two different things. Okay? Atoms of different elements have different masses. Well, that stands to reason. If you've got, if the atoms themselves are different, their masses are also going to be different. Did I say there were four parts? Part 5 says that atoms can't be split up by ordinary chemical means. Now, can you split an atom? Yes. 99% of chemistry, though, we're dealing with reactions that happen when atoms are interacting with other atoms. We're not talking about an atom being split. That's a special branch of chemistry called nuclear chemistry, and we will talk about it sometime in the spring. And that's the end.